problem number 2, we got a ball that's being launched from flat ground this time at an angle that we don't know. Here's some flat ground. Here's a ball being launched at an angle theta equals we don't know. So it's going to fly through the air, and then it says it's going to come down to the ground with a final x velocity in the x direction of 19.32 meters per second and a final velocity in the y direction of 5.18 meters per second downward. And that downward is a very important word for our formulas, because when we write that number in our formulas, if we call downward, or if we call acceleration due to gravity, for example, negative 9.8 meters per second squared, then it's very important that we call this final velocity negative 5.18 meters per second, because it's also going downward. So that's just something to make sure that you do when you use these equations. All right, so what is the time of flight? Well, let's think about what we know. Usually when we try to find time, we're looking in the y direction. The reason for that is because the x direction, there's only 3 things because acceleration is 0. So the final and initial velocities are the same. Acceleration is 0. We can only find out how long it takes if we know how far it goes. So usually we go to the y direction. In the y direction, we know gravity, negative 9.8 meters per second squared is the acceleration in the y direction. They told us the final velocity in the y. Remember, it's negative 1.8 meters per second. Okay, we want to know time, but there's this rule of 3 that says we need to know 3 things. So what else do we know? Do we know the initial y velocity? You can make an argument that we do. Sorry. But what I'm going to say is that we know delta y. Delta y is the change in position from start, which I'll call this the start, to the end, which is right here. Well, how much does the height change? It doesn't. 0. So we're going to look for an equation that has a delta y, the final velocity, and time. Does such an equation exist? Of the ones that we have, I think the answer is no. So what should we do? Well, we can find the initial velocity, and then we can work the equation to find time. So I'm actually we'll do time in just a second. We're gonna go to the equation that doesn't include time. V final squared equals V initial squared plus 2a delta y. We plug in final, negative 5.18 squared equals V initial squared plus 2 negative 9.8 times delta y, which is 0. And so what we get here is something that's kind of interesting. Actually, so this whole 2a delta y goes away, and we see that V final squared is just equal to V initial squared because the delta y is 0. Very important. When the delta y is 0, the final and the initial are the same. So what do we mean? Is the initial velocity just negative 5.18? Well, no. So at the end, we've got 5.18 meters per second, but it's going downward, so we call it negative. But at the beginning, when this ball is first launched, it has a positive y velocity, so 5.18 meters per second. 5.18 is the initial velocity. So can you use this? Absolutely. This is another one of those things that we can just know. If the delta y is 0, so if this thing's on a platform, we don't know the final velocity when it hits the ground. Only if it starts on the ground and ends on the ground, or if it starts on a platform, then we'll know the velocity when it gets back to the same height as the platform, but not necessarily when it hits the ground. So we now know the initial velocity is the same number, just the opposite direction. And what we will do with that is we can use any equation now to find time. Let's use equation number 1. Final velocity is equal to initial velocity plus acceleration times time. So I'm going to subtract this over. It'll become negative 10.36 equal to negative 9.8 t. T is equal to If you're wondering why I didn't include the negatives, it's because they don't matter. Negative divided by a negative is positive 1.06 seconds. Okay, let me do another thing that we can do to find the time. If you want to skip over this, this is probably going to take me about a minute, and so feel free to do that. If we know the final velocity in the y direction is negative 5.18, call that the v final in the y. Another thing that we can do is we can break this flight up into two sections. So we'll actually just look at everything from the top of its flight to the end of its flight. And why would I be interested in that? Well, because at the top of the flight, I also know the velocity is equal to 0. And I know acceleration is equal to negative 9.8 meters per second squared. And so I can use this to find time, but it's only the time from the top to the ground. Well, it happens just like the velocity is the same before and after. The amount of time from the beginning of the launch to the top is the same as from the top to the bottom. And so I can use this to find time, but it's really just half of the time, and I can multiply by 2. So negative 5.18 is equal to 0 minus 9.8 t. T is equal to 5.18 divided by 9.8. And so you'll see that these are exactly half. If I multiply by 2, ding, 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 you get the same number. And that's just by cleverly splitting this problem in half. You can find this is actually half of the time, 0.528 or whatever it was. Yeah. All right, back to it. So now we know the time of flight. We can find the highest point that the ball reaches. Like I was saying over here, at the highest point, we know different things. So we know the initial velocity is 5.18. We know acceleration is negative 9.8. And we know at the top that the final velocity there, if we call that the end of the flight basically, is 0. And so we can use these to find delta y using equation 4. Now that we know the time, we could cut that time in half or use this number over here as time, and we could use any equation we wanted to. But let's just assume we know these three things. V final squared is V initial squared plus 2a delta y. Final is 0, 5.18 squared plus 2 times negative 9.8 delta y. This is negative 19.6 delta y equals, that's not what I want to do. Let's find 5.18 squared. 26.8 minus equals 0. So you're going to add 19.6 delta y to the other side. You get 19.6 delta y equals 26.8. Then you divide by 19.6 on both sides, and you'll get delta y equals Notice how I just used the answer, so I just hit divide, and then it's going to take this whole thing and put it down here where it says ANS, answer, and I don't have to worry about this being rounded. I don't have to round it to 27 or 26.8. I just get the full answer, 1.37. That's how high it's going to go. Which should make a little bit of sense because it doesn't start off with very much y velocity at all. How far does the ball travel? Delta x is just vxt, so that's 19.32 times 1.06. You might be thinking, hold up a second, Vx, that's V final x. Well, what do we know about the x direction? We know that there is no there's no acceleration, so the V final is the same as the V initial in the x direction. And we get that it goes 20.4 meters. The initial velocity, let's do the angle it comes down with. So again, this is the same as the previous video. I'm not even going to do the whole thing. You got negative 5.18 and you got 19.32. If you want to see how to do that, go watch the first video. It involves doing tangent inverse of this over this. And then the initial velocity is a question that is asking you for, it should just say the magnitude of that velocity. So we don't care about the direction, we just want to know, like when the thing comes out of the cannon, how fast is it going? So you take the final velocity in the x direction plus the final, or initial velocity in the x direction squared equals the final velocity squared. Okay, so we're not asking about either component, we're looking for what's known as the resultant here. Resultant. So we plug in those numbers. Wait a minute, why am I like this? I need to go home. V initial in the y squared plus V initial in the x squared. I'm so sorry. So we do initial in the y. I said that's 5.18 squared plus 19.32 squared equals V final squared. It doesn't equal V final? Y'all, I'm having a hard time. V initial squared. Wow. Okay, V initial. Sorry. If we're looking at components of the initial velocity, then at the end we will find the resultant initial velocity. So this is like, practically speaking, if we're launching this out of a cannon, how quickly is it coming out of the cannon? 5.18 squared plus 19.32 squared. Square root of that should be about 20. Indeed it is. This is a cannon firing it at 20 meters per second, and that is the magnitude of that initial velocity. So not the direction. We could find the direction using an inverse tangent, but we know how fast it's being fired. Thanks for hanging in there. One more.